Okay, dear students. So in this video, we are going to learn about another kind of a vertical circle, which is quite popular with IB. So be very careful here. Okay. Now, what happens is there are some circular motions which on the surface looks like a vertical circle, but they are not. So one such example is when you talk about these satellites. Okay. And they will say that there is an astronaut and, he is rotating a bob in a vertical circle. Now, this astronaut is in the satellite and he is rotating the bob in a vertical circle. So, in the question paper, it is written vertical circle, and people will feel that yes, it is vertical circle, but it is not. Why it is not? Because in the satellite where the astronaut is there is no gravity, and because there is no gravity, we can say that these equations that we just derived in our video there, those are not applicable here. So the vertical circle in the satellite will will be same as that of the horizontal circle because there is no gravity. So we will be just it will be suffice to say v is equal to r omega is equal, isn't it, like a is equal to r alpha, that's it. Like there will be centripetal force, there will be centrifugal force, nothing complex will be there. The only thing is that they have written vertical circle, but beware, it's not vertical circle. That is the first case that I'm telling you here. Now, there is another case which we are going to discuss now. Again, even in this case, they will say that it is a vertical circle, but the formulas that we have derived, like the minimum velocity is root 5 gr, these formulas will not be valid in that case. And what is that case? When we say that it is not a string, but this is a rod here. Okay, this is a rod here, and the bob is like just a, this is a bob which is attached to the rod, and obviously the rod is not like a string that it will be, it will slack after some time. It is not like that. And moreover, it is attached with a motor at the center. It means that it is moving with a constant angular velocity, just like a table fan or a standing fan, you can say. So it is moving like a standing fan. So omega is a constant value because omega is derived from the motor which is attached with the rod at the rear end. Do you get my point? So it's actually like gravity is there, but gravity can't do anything. So gravity is not able to influence the motion. So this is a vertical circle, and there will this will be a different kind of a phenomena. Equations will be different, formulas will be different, but we can say that yes, it is a vertical circle, but still the formulas are not valid. Why? Point number one in these kind of questions, omega is constant because omega is determined by the motor. So the motor is running at some certain particular angular frequency or angular velocity, so that will be that. And accordingly, we can say v is equal to r omega. It means that the tangential velocity at all the points, at all the angles, whatever it is, this, wherever the bob is, this velocity is not going to change. So it is just like moving like a fan. And so the speed is not changing. Velocity is a vector. So we cannot say that the velocity does not change, but we can definitely say that the speed does not change just because of the direction. So the speed of this is not changing. It is moving with a constant velocity. Still, there will be some questions, and about what? They will be about the tension in the rod. Now, let us see. So now I'm going to concentrate at the top end. So at the top end, you see the weight is acting downwards. And again, I'm using the concept of centrifugal now because I want to be clear 100%. That is why. And then we can adapt it according to the centripetal whenever you say. So this is the force which is mg, and we are not we are not confirmed about what is t2. We want to find t2. So this is this, and there will be a force which is centrifugal. Again, this is just for your rough work, just for thinking. This is centrifugal force. So what is the net force with which this bob is putting a force on the rod? Like this bob is now pressing the rod, but what is the force with which it is pressing the rod now? So that will be mg minus the centrifugal force, isn't it? Mg is going to be bigger force. So we can say, or we can say fcf is equal to t2 plus mg. We can say that also. No problem. So T2, yeah. So T2 will be mv square by r minus mg. If omega is given and you want to talk in the terms of omega instead of velocity, you will say that the centripetal force or the centrifugal force would be having formula mr omega square minus mg. So this is going to be the tension at the top. Okay, obviously it is going to be the minimum. And I show you. Now, let us move to the bottom end now. So what is happening at the bottom end now? So at the bottom, this is the mg weight, which is downwards, and centrifugal will always be away from the center. That is the fun part, like that's why it is so easy. So centrifugal will be this, and T1 will always be towards the center because it is the part of the rod. That is why. So here, clearly, T1 is found to be equal to the sum of the weight and the centrifugal, which we can write it as mg plus mr omega square. Clearly, this is going to be the max and this is going to be the minimum. And so, in this kind of a standing fan or a table fan, we can say that the tension, like tension, or you can call it, yeah, tension uh, in the rod will be maximum at the bottom and it will be minimum at the top. Well, it was the same case with the other kind of circular motion also, but the phenomena is different. Like in this case, mr omega square is completely constant in both of these. Here and here, mr omega square is constant. Centrifugal force is same. The velocities are same. This velocity at top and this is the velocity at bottom. Now they are equal to each other. The velocities do not vary. Omega is constant, velocity is constant. That is why this kind of circular motion is completely different from the earlier vertical circle that we did. So be very careful if you are getting question on this. And the tension in the rod will always be different at all the points. Okay, dear students, so this is it for this topic, I believe, and we would be moving to the next topic now. No problem. If there is any doubt that you want to say, you want to ask, you can ask in the doubt class that we are going to conduct on the Sunday, or you can post that on the WhatsApp, okay, or you can contact me anyways. You can mention that in the comment section also. Please share the video with all of your friends. All the best. Bye. See you in the next video.